Hey y'all, we're going to actually look now at zeros and multiplicity. So a problem asks you to find the zeros and the multiplicity. Okay, so zeros are what makes our function equal 0. So the way we would find our 0 is to set our function equal to 0 and then solve. Our multiplicity is the number of times you have that solution. If your multiplicity is odd, then your graph crosses at the x-axis at that 0. If your multiplicity is even at that 0, the graph will touch and turn at the x-axis. Okay, so if we have f of x equals 7 times x plus 4, and then that's all times x minus 9. The way I'm going to find my zeros is to set my function equal to 0 because I need to know what makes my function 0. Those are my zeros. Okay, so what I would have here, I would technically divide both sides by 7. You could either do that or you could do, you would divide both sides by 7. I was going to do it another way, but this is going to be better. Now we would just have x plus 4, and we would have x minus 9 all squared. And so what you do is you take both of these factors and you set them equal to 0. And so what we would get is x equals negative 4. And then my x and then that minus 9 all squared. What you do is you take this whole thing, set it equal to 0, and then we learned the square root property, which states that that doesn't look like a square root. We could take the square root of something being squared, and what happens is it cancels. You could take the square root of our right-hand side, being sure to add plus or minus, and then what we have here is just x. We have minus 9 equals plus or minus the square root of 0. The square root of 0 is 0. Technically, there is no such thing as plus or minus 0. It's just 0. So what you do is you just write 0, okay? And then solving this, what we would get, I'm looking at my paper right now. I'm trying to figure out why I have a negative 9 for my x. And then I wrote my 0 as a positive 9. So that's just a little typo on my part. Typo is my middle name. Solving this, I would get x equals 9. So my zeros are negative 4, 9. Okay, now as far as my multiplicities, if you look at my factor here of that x plus 4, it has an exponent of 1. So my multiplicity, we could say negative 4 has a multiplicity of 1, which is odd. So that means it crosses. And it's actually going to cross at negative 4. Okay. Now, if you look here at my factors, that x minus 9, that's actually being squared. That's the multiplicity. So what we have is my 0, my 9, has a multiplicity of 2, which is even, which means it touches and turns. And so that will be the answer to that problem. This is kind of building towards what we're going to do in the bigger problems. But for this problem right now, what are your zeros? And then, we didn't say right here. My 9 has a multiplicity of 2, which means at 9, because my multiplicity is even, it's actually going to touch the x-axis and then turn. Okay, So I don't think I wrote anything else, but we should be able to do a little bit more on this video. Let me zoom in or not. Okay, so there's something called the leading coefficient test, LCT for short. And the leading coefficient test says, I wonder if this will actually work. The leading coefficient test. Okay, so I'm going to do a little table. Boom. And I need to do that. And I need to do I saw that I could do tables and I got interested in it. There we go. Add one this way, add one that way. That's actually perfect, but it is way too large. So it just is what it is. Skim right over it. Okay, the leading, oh man, I still need to add one more. Yes, I need to add one more. How do I add one more? Of course. I'm gonna add over here. Oh, wow, look at that. It did it. Okay, so now I can do it. The leading coefficiency test. Okay, if our A is greater than 0 and my leading, my degree is odd. So my leading coefficient is the A. If that's greater than 0 and my degree is odd, then what you do is your graph falls to the left and it rises to the right. If your leading coefficient is greater than 0 and your degree is even, then what happens is it rises to the left and it rises to the right. Okay. If my leading coefficient is less than 0 and my degree is odd, it rises to the left and it falls to the right. And if my leading coefficient is less than 0 and my degree is even, what happens is it falls to the left and it falls to the right. Okay, so whenever we're given a function, we're going to figure out using the LCT, the leading coefficient test, basically the end behaviors of our graph and which way it falls and rises. We need to know the X-intercepts, the Y-intercepts, the multiplicity, whether or not it crosses or it touches, and the Y-intercept. And then after all of that, we can graph. Okay, so let's say this is our function. Say we have f of x. You know what? Let me do it right over here. I guess that's it. And say we have f of x equals x cubed, a positive 4x squared, a negative x, and a negative 4. Okay, so leading coefficiency test, I can see that my A, I don't like that one. There we go. I can see that my A, which is the leading coefficient, which would be the coefficient attached to my x cubed variable, that's a 1, and it's a positive 1. But I know for a fact that since my A equals 1, it's greater than 0. And I can also tell that my degree equals 3, which that is an odd number. So right now I am looking at row 1, column 1, which is greater than 0 odd. So this tells me that it's going to fall to the left and it's going to rise to the right. Okay, so it wants me to find my X-intercepts, which we definitely know how to do that. if we want to find our x-intercepts, this is where our function equals 0, and f of x is the same notation as saying y equals 0. And if we do this, there we go. What we do is we make our f of x equal 0, and we have x cubed. We have a positive 4x squared. We have a negative x, and we have a negative 4. Okay, so when I look at this, trying to figure out, okay, so I've got 4 terms here. That goes ahead and lets me know that I'm not going to do the AC method. I'm not going to do the quadratic formula. I'm not going to do any of those. Because I have 4 terms, what you do is factor by grouping. And so you would actually split these 4 terms down the middle. We have 0 equals, if we pull a greatest common factor, we have x squared. X cubed divided by x squared is keep and subtract. And then 4x squared divided by x squared. 4 divided by 1 is 4. Signs are the same, so it's positive. X squared and x squared, when you do that, technically what you end up getting is x to the 0 power, and anything to the 0 power equals 1. So it's like saying 4 times 1. But technically, like, you don't have to write that, okay? Whatever sign is here, you bring it down, and then you look to see what the greatest common factor is of an x and a 4. And they don't have anything in common except for 1. So here we divide, and we get x divided by 1 is x. Signs are the same, so it's positive. 4 divided by 1 is 4. Signs are the same, so it's positive. So what you do here is you check to see. Oh, it won't let me delete it once I do that. You check to see, you've got 0 equals, that looks funny. You check to see if your factors are the same, if your parentheses are the same, and they are. So because they are the same, all I need to do is just bring one down. And then this leftover right here, that goes into a set of parentheses together. And then now that I've done this, what I can do is actually use the zero factor property, which states that if you have factors set equal to 0, you can take each individual factor and set them equal to 0. So x squared negative 1 equals 0. Okay, on that left-hand side, I have x plus 4 equals 0. I need to solve for x, which means I need to use the additive inverse of a positive 4, which would be a negative 4. And so I would get x equals negative 4. Looking at my parentheses, I notice that it has an exponent of 1. So here I have one of my zeros, right? It's negative 4 with a multiplicity of 1. And honestly, y'all, it's your own notes. You can write whatever you want. In the homework, it'll thoroughly describe kind of how to answer it. So you should be able to pick out which one it is. If I look on the right-hand side, you can notice one of two things. You can notice that that's a difference of squares, and you could use the template, factor it, have both factors set equal to 0. Or you can notice that this is in ax squared with a constant. So that right there is our square root factory, not factory, square root property. Okay, and what that would have me do is isolate my variable. So I would get x squared equals 1. And then you would take the square root of both sides. So I would get x equals plus or minus 1. And that would be, I've got 2 zeros there, right? I've got a positive 1, 0, and I've got a negative 1, 0. And I'm just making sure that I don't have any like exponents or anything here that I didn't account for. I'm good. If I look at the exponent on my original factor of x squared minus 1, it's a 1. So this would tell me that I have a negative 1, 0 with a multiplicity of 1, and I have 1 with a multiplicity of 1. Okay, so let's see, multiplicities of 1, that's an odd multiplicity, so it's actually going to cross. Let me see. all three of those are going to cross, right? And then let's do our y-intercept so we can actually graph this. If you do your y-intercept, this is the same thing as saying that x equals 0. The function notation, like what we're going to use whenever we write it, though, is actually going to be f of 0. Because usually it's f of x, right? But now my x is 0, so f of 0. And quite literally what we do is we plug 0 into our function wherever we see an x. So f of 0, well, that went to 0. 0 squared went to 0. 0 times 4 is 0. Negative 0, 0. I get a negative 4. Okay, and then let me see. That should be all we need to actually be able to graph this. Okay, so let me actually insert a graph here real quick. I'm going to do a 5 graph. I don't really think it matters, but let's just see here. I need that to be larger. And I actually want it to be, I'm trying to just grab the graph, but it does not want me to move it. Touch the graph, move the graph. Move the, okay, let me touch one more time. Touch the graph. Move the graph. There we go. Perfect. So what do we know? Let's see. Let's start up here with my a is equal to 1, which is greater than 0. Okay, that helped me figure out that it was going to fall to the left and rise to the right because my degree was odd. So literally, what I'm going to do is I'm going to show you, this is what you do whenever you learn like fall and rise, okay? So you just kind of, I'm trying to make sure I put it correctly. I think it's going to be like here. I really want that to be a thick, I'm probably going to need to zoom in. Okay, so whenever we're falling, I'm literally falling to the left, and it told me that I'm rising to the right. So I know that that's going to be the end behavior of my graph. Now, if I look at my x-intercepts are -4, a 1, and a +1, right? So I'm going to go to -4, which is right here. So already I know that I need to move my arrow. So I would probably do my dots first, like plot my points first, and then let's go ahead and see the end behavior and what happens to the ends of our graphs. So -4 right here, and then a -1 right here, and then we're going to have a +1 right here. So those are x-intercepts and x-intercepts. Now let's go to my y. F of 0 equals -4 is saying that, my y, when x is 0, so that would be right at the origin, is -4, which means you just go down to -4. Okay, so having these dots doesn't really help you figure out, I have no idea where to start, where to go, which way to turn. That's why we do the leading coefficient test, so that if we're graphing something, we know pretty much where to go and where things point and where they came from. This is where I want to go ahead and do my, I wish this would get better. Okay. This is where I'm going to do my ends. I've got one here because I know it's falling to the left. And then I'm going to have one here because I know it's rising to the right. Now what we can do is actually connect these, right? So it told me that because of my multiplicities for all of my x-intercepts, the graph crosses. So I'm going to do this. I want to try to do it in this. Starting at my end right here, I am crossing at -4, and then I'm going to cross at -1. I'm going to go down to my y-intercept, up to 1 where I know it crosses, and then connect right here. So that's my actual graph, y'all. I'll do an example where it actually touches and bounces. Not really a real example per se, but if I cross, I do this. If I touch and bounce, you literally you touch it and then you come back down. You don't cross over it. This is a cross. This is a touch and bounce. But I'll do an example like that because it is going to be different than this particular example. I think that's it, y'all. If you have any questions, make sure you let me know, okay? Thanks. Bye.